We're having improvisation here. Yeah, thank you for coming. My name is Richard Anderson. 1994, Guy Van Cleve and I started the Science Colloquium. That's what this is. And for 20 years, every week we had a science program for the Science Colloquium. We called it, I'm sorry, we called it the Kickback Science Seminar in those days. And then we had COVID, and of course that kicked everything in the head, and we're recovering from that. So I appreciate you coming, especially our speaker. And I'm just wondering if some of you can tell me, why did you come? Were you sent for extra credit or what? Anyone volunteering? Well, I'm glad you're here anyway. Okay, so in 1849, the gold miners had a lot of trouble with malaria. It had been introduced from the European continent for pelt seeking, and here it was, and we had malaria here. So keep that in mind. And we have perfect conditions for growing malaria organisms. Fortunately, we don't have malaria organisms. He'll talk about that. But by 1919, it was such a problem, they decided to make mosquito control districts throughout California. And that's why I have the pleasure of introducing our speaker today. Dr. Wakoli Wakesa is from Nigeria, and he has already been the director of two other mosquito districts, and he's been here now 4 years, I think. Yeah, thank you. He started his education in Nairobi, University of Nairobi, for, I guess, BS and MS, and then came to UC Davis for his medical entomology degree, doctorate. And so he has been taking care of us. And I thank you, and I'd like you to welcome Dr. Wakesa Wakoli. Wakoli Wakesa, sorry.
Thank you. Thank you. It worked.
Okay, cool.
Thank you very much for welcoming me here. I hope that is good. As you heard, my name is Wakoli Wakesa. I really don't mind my name being butchered here and there, because that's what it is. It's a little difficult to pronounce. And I'm looking around and say, man, I'm not that popular, or mosquitoes are not that popular, but I know it's winter time. If you talk about mosquitoes in winter time, not a whole lot of people pay attention. But if it was August, I think this place will be full. And I brought my colleagues here. I told them if the tomatoes are thrown away, I'll duck and it'll hit you. I have my colleagues here, the lead staff at Eastside, Jason Boring and Tom North. They work with me over there. They take a few punches here and there for all of us. My talk, I didn't know whether the audience a little bit, and I'm glad I'm invited here. So I prepared a talk as if it's a lecture.
Good.
And that's what it's going to be. So you're going to bear with me. It's a lot of detail, but the details that are fun, because we can take them home and use them, at least choke your memory or use them for tomorrow, because mosquitoes are going to be here. The weather is changing, and they'll be here anytime now. Now, when I saw the invitation, I looked at it and said, man, that reminds me of home. I was born and raised in Kenya, and those baobab trees are mainstay if you're driving to, you see?
Oh no, you use the arrow on the
Just the arrow on the,
on the,
okay.
got it.
If you're driving from Nairobi to Mombasa, the baobab trees are the mainstay out there. And last March, I was heading actually heading to see my brother in Mombasa, and that's one tree over there. But it's not as clean as the one that was on the flyer there. It has quite a lot of scars on the side because people use the bark for medicine. So it's gotten a few wounds there over the years for folks looking for medicine off the tree. As you heard, my name is Okolo. Been manager Eastside since June of 2019. It's almost 4 years now, and I love it here because it reminds me of home. I deal with the country, rural situation every day. It's just fun to be here. And this year, I'm actually also the president of Mosquito Control Association of California, 2023. So, as I said, I didn't know the audience well, but I thought I'll break my talk into parts that I can digest and help the audience also digest a little bit. So it's more of a lecture, but also things to take home for as we walk through the history and what we do as an association for the state and as a district here. You guys don't know, but Eastside is a memorable, very well established district since from the beginning. One time we were the center of mosquito control literally in the world, 1949, literally. The whole world came here to see what Eastside and the state of California does in mosquito control. So I'll walk you through it. So I have 4 parts for my talk, actually 5. History of mosquito control in the state and that of Stanislaus County, mosquitoes of the Central Valley and our county, the surveillance methods and potential diseases they may transmit, mosquito management and control, and then at the end I'll talk about the new arrival in our neighborhood the last 2-3 years. We call them exotic mosquitoes, but in general call them invasive Aedes. One has made it here, there are 2 others on the way. They could get here anytime. It's always good to know, or at least to be in the know. And thank you, Richard. As mentioned, during the gold rush in 1840s, 49, 50, malaria came with folks who showed up in the state. In the foothills, we got malaria, a place called Penryn in Auburn, as you go to Auburn. That was a settlement of most immigrants that were coming perfect for gold, and malaria settled in. A lot of Brits, folks from England, from around the world, they came out there. Malaria became a prevalent disease. But by then, nobody knew that malaria was associated with mosquitoes. So they never worried about the mosquitoes in the area being the source of the transmission. This information came about in 1898. Sir Charles Manson, working in Southeast Asia, observing through a microscope, saw filaria worm in a mosquito salivary gland, 1898. 1901, a French scientist working in today Algeria found literally what looks like malaria parasite in the salivary gland mosquitoes. And by 1903, of course, in the news around the world is the association of mosquitoes and malaria. What it is, malaria was generally considered bad air. Actually, in Italian, it was bad air. Associated malaria with the season. When it gets cold and wet, people get sick from this ailment. They could die from it. And then malaria, of course, the parasite was known from there. 1903, the precursor of mosquito control in the state of California, other than the disease, and of course knowing the mosquitoes in the valley were words of them, didn't know what to do about it. A group of folks in Marine San Rafael, which were actually an improvement club, they came together, wanted to improve the neighborhood. They could not manage mosquitoes, and they thought we'll look for a professor to help them consider that. Professor Wickleworth at UC Berkeley was commissioned, was actually given a small grant to find ways to reduce mosquitoes for them in San Rafael. And he managed, got a bunch of students, they went and drained essentially the marshes nearby. Voila, the season, the summer was a lot more palatable. And they thought if we reduce the outcome will be that. Similar improvement clubs in San Mateo, in Alameda, actually had money for the following year to ask for the same. The same professor went out in the summer with his students, summer students, and did the same. Following year, he said, I'll get better. He hired a student, actually gave him a job, Quayle, who became a famous man, to help him in 1906. And then, that 1906, we had an earthquake in San Francisco, messed up the whole neighborhood, but the seed for mosquito control was already planted. 1908, a professor was hired out of New Jersey. His name is William Hams, by UC Berkeley, this time for just mosquito work. He was a malaria specialist. Then, when he came here, he found actually the biggest problem people had, other than malaria in the foothills, was just a nuisance, the bites of mosquitoes, just horde of mosquitoes, many of them, and he turned to focus on that. Tried to pass a mosquito control law. It took a while for him working with a politician. You won't believe the owner of Italian bank, which became Bank of America, was at the center of that. Him and one the real estate developer with Professor Hams literally convinced the politician, and in 1915, Governor Hiram Johnson signed the law, mosquito abatement law, onto the books. And that's where mosquito abatement districts were created, 1915. A few years later, we went to First World War, and things slowed down a little bit. But most of mosquito people went into the war. By the time they came back, they had a few more knowledge and impact on what we have today as mosquito control. That law, mosquito abatement law, created essentially three things: authority for the formation of districts, how to form them. The cities can come together, county and folks form one, provided governance structure and funding of those districts. Funding comes from property assessments, from the area being served, or in addition, benefit assessment. Each property assessed a penny or two or whatever to put money together for that purpose. Some areas with the state were focused then on disease. As I mentioned, malaria was the main thing, and a few diseases were discovered later. But other areas still insisted on actually controlling the nuisance mosquito issue. Those who insisted on controlling nuisance really didn't like these big acts for disease, and they opted to follow the law that was being used in weed control and others, which was a pest abatement law. When we came into being, that East Side, in 1939 to form a district, our district went through that law and left a mosquito abatement law that had been passed in 1915. 1930, there was a mysterious disease that actually in the Central Valley sickened a lot of horses. More than 6,000 horses and mules literally died in this valley, including right here in our area. In 1931, professor from UC San Francisco Hooper Foundation, Carl Myers, and then experimental station, or UC experimental station, which became UC Davis, C.M. Herring. If you've been on campus at UC Davis, is Herring Hall. That is the name of this gentleman or this professor. The two of them wanted to get a horse that was sick, not dead, but sick. And they couldn't get anybody to give up a horse for the experiment. They came right here, I think in Merced County, and I've been looking for that street to know where. The gentleman would not give the horse, but the wife say, you know what, this horse is gonna die anyway. Sir, on the side, if you can, I'll sell you that horse. For how much? $50? And don't make sure my husband doesn't know. How will we get the horse? I say, leave the $50 under the shoe on the doorstep, but you can come. The horse will be in such and such. Take the head. They wanted to get the head. Take the head and go. And actually, that's what they did. They came left the money, got the head of the horse that was sick, dying, and went back. The following day, the brain of the horse was in culture and cultured it. From that they discovered the disease we know today as Western equine encephalomyelitis that we know today. Discovered 1931, and a few years before that, they'd found another disease called St. Louis encephalitis that had sickened people in Philadelphia just a few years before that. So that's 1931. And our association, California Mosquito Control Association, was started that previous year, 1930. And we're today 93 years old. 93 years old as an association. So in 1939, July 26, East Side was born. The Board of Supervisors in the county decided they're going to create a special district, and they passed that law and appointed staff, essentially appointed trustees, 6 of them, which today we still have 6 trustees that serve on the board. And in November, they hired their first manager, Chester Robinson, to actually be the first man as a superintendent, which is the same as actually manager today. And the Board of Supervisors supported the district with money, and a few farmers who were essentially concerned more, farmers and ranchers in the county were involved in supporting that district to grow. We cover, from then, Tuolumne River North, and a new district, another district formed a few years later, Tulloch Mosquito Abatement District, formed below on the south side of that. They went under the law, mosquito abatement law. East side was formed under pest abatement law. 2 different laws, one by one. We are the biggest in that law. Actually, we're the biggest district in that law. The rest of the state are in the mosquito abatement law. And there's, what would I say, funding structure that is fairly different between the two of us and Tulloch. We can not do benefit assessment today, they can. And so that structure constrains us in a little bit, but I just wanted to emphasize that in why we have 2 districts in the same county, right? Some of the folks who really were instrumental in growing the district were, example here, in 1956, we moved from where we were, downtown Yosemite, to where we currently are stationed, just east of the Modesto Railway Station, Amtrak station. But before that, we had a runway actually built by Mapes, Ed Mapes, on Mapes Ranch and Faith Ranch. And here is a construction of that in 1959. And our pilots then, Porter, and our manager, second manager, Gordon Smith, in that photo there. So what does the law provide? And essentially these to help you know how we operate and how we do our work. The districts, both pest abatement and mosquito abatement under Chapter 1 of the Health and Safety Code, mosquito abatement district under Division 3, pest abatement under Division 8. The laws intertwine to actually make us function as they were. The district draws its authority to conduct its operation from these laws. Districts that under Division 3 can levy special benefit assessment. Under Division 8, our laws are still hanging. We cannot just do that. So we depend on ad valorem. This is important because in 1978, when ad valorem was changed through Prop 13, Eastside had 25 full-time employees. We dropped from 25 to 3 because all our revenues disappeared. Tulloch was able to go out 2 years later and pass a benefit assessment and recover their essential revenues as such. The purpose of districts, essentially in 4 parts. We are charged to conduct surveillance and do appropriate studies to understand vectors, which mosquitoes are part of the vector system. Take action to prevent occurrence of vectors, take action to control or abate vectors, and take any action necessary for the powers granted by this law. And I've highlighted three things there: conduct, prevent, and action to control or abet. What does that mean? Here, the meaning. Under the law, abet means put an end to or reduce the intensity of a public nuisance. So mosquitoes, under the law, public nuisance, not necessarily disease. Control, prevent or reduce vectors. And the last part is public nuisance. This is where it's most important. And if you follow the strict part of the law, we won't do our work very well. But public nuisance is any property artificially altered from natural condition that supports the development or attraction or harborage of vectors. Mosquitoes are included. Underline artificially altered. Any water that is breeding place for vectors, any activity that supports the development, attraction, or harborage of vectors, or that facilitates the introduction of spread vectors. So anywhere in the jurisdiction where water stands, if it's natural environment where water stands, the district has all the responsibility to do everything they need to do to control those mosquitoes. Now, where water stands, that is a natural, been altered in any way, so essentially artificially altered, pasture, a ranch, around your home, in a swimming pool, that is altered. The responsibility shifts from the district to actually the property owner. Any property owner who therefore has water standing on their property takes responsibility of controlling mosquitoes that comes off that. The district should educate, teach, show, essentially hold a hand until they can be able to control that. Meanwhile, but the ultimate end, they're responsible for mosquitoes that comes off that. That's the law. Now, where districts deal with disease, that's a very different situation, because disease can be quite amorphous. They're responsible to cover that. Many districts don't deal with the nuisance. Mosquitoes that come out of a district, many of them are actually a nuisance. They bite relentlessly. And that is what we try to manage and help folks to reduce the biting intensity, the nuisance. But the disease is very different, and I'll go through to show you what I mean by that. Any questions? That's a history a little bit, and the law that actually guides us in how we do our work. Mosquitoes is not boring. When they bite, you can't go to sleep. You can't do anything. You can't barbecue. So what are these buggers that really ruin our environment? And I have at least so many mosquitoes here. In the Central Valley, in the state, we have more than 39 species of mosquitoes. But there are some are more important than others, like Animal Farm, as far as we're concerned, because of what they feed on. But I have only 3 main classes of mosquitoes that really are menace to us: Anopheles, Culex, and Aedes. And from here today, when spring comes around, you'll be able to have an idea what is biting you. Look carefully, you'll be able to tell. Anopheles species, they mainly transmit malaria, and we mentioned that. If malaria got here, somebody got here sick in transmission stage, and these mosquitoes beat on them, they will acquire the disease and they will most likely can transmit it. So we have mosquitoes here, but no malaria. Culex species, the main one that really are menace is Culex tessalis and pipiens, and I'll give highlights a little bit later. They transmit Western equine encephalomyelitis, St. Louis encephalitis, and West Nile virus. We have another one called California encephalitis, which is rare. But those 3 are the main diseases we deal with here. We get these diseases all the time. And then the Aedes species and 3 groups. This one is important. I'll break them as pasture mosquitoes. We have Aedes melanimum, nigromaculus, and vexans. Most of our pastures here along the riverines are there. The nuisance we deal with, if you're outside town, that's it. Most likely when the call comes, June, July, where are we? On the outskirts, and most likely those are the mosquitoes. And when they bite, they don't relent. Until I got here, I will have dismissed anybody who argued about that. But they're here, and they are menaced, and they don't stop. When they come to you, you can swat them, but they will not leave. They'll just and come right back to you. They're very, very aggressive. The other mosquitoes I'm used to, and those ones we can deal with, the tree-hole mosquitoes, Aedes syrensis, they transmit dog heartworm. Oh, the other one, passenger mosquitoes, really don't transmit disease much. They're nuisance. If we know it, we'll just ignore them, or we don't. But they don't transmit anything, nuisance. Tree-hole mosquitoes, we go to Nice Ferry, along the way, they're actually common. Early spring, in April, May, they'll be the one mainly biting. They live in tree holes, and then they emerge as the spring thaws out. They transmit dog heartworm. Then invasive mosquitoes, those are new ones. In Stanislaus, now 3 years, we have Aedes aegypti. The other two, Notoscriptus and Albopictus on the way. In Los Angeles, we have all the three. And I was working there only a few years ago. If they were here and disease got here, dengue, chikungunya, and Zika are what they'll transmit. And if you've heard before of yellow fever, is one of them. All these three diseases have occurred in the United States, at least imported. The first one, dengue, is already here, being transmitted in the country. Anopheles mosquitoes, a little more detail. Anopheles freeboni, franciscanus, punctipenis. They were vectors of malaria. 1952 was a major outbreak. Quite a bunch of people got sick in Auburn. Lake Vera was the area, and we have, over the years, imported cases in the Central Valley here. Returning folks from abroad, World War, another World War, was the North Korea War. That was actually an outbreak from 52. And folks returning from the tropics tend to bring them back, and we have a few cases here and there. They feed mainly on mammals, mammalian host, Anopheles. Their habitats, clean flowing water, vegetation, shaded vegetation, most riverbanks, canal, rice fields. That's where you find them. Culex, the main one I mentioned, pipiens, and Tassalis. They're common here. Stigmatosoma erythrothorax are rare in dairy out there. They transmit the diseases mentioned, Western equine, St. Louis, and West Nile virus. They mostly feed on avian host, unlike the Anopheles. Their habitats vary. Some require clean flowing water, others require stagnant, high organic matter water, vegetation, some in dairy lagoons. But these are the main ones that I need to significance of it. Pipiens and Tassalis. If you're in an urban area and you get bit when you're outside your house, they're not the pasture mosquitoes. Mostly they're this one, the pipiens. Pipiens is a mainly an urban mosquito. They breed in storm drains, they breed in bad swimming pool, they breed any standing water that is around your yard. Stands for 3-4 days, that will produce pipiens. And they are very good vectors of West Nile, Western equine, and St. Louis encephalitis in urban areas. When we have outbreak of the West Nile, these are the mosquitoes that are transmitting from north to south of the state. And when we are working very hard to control mosquito for disease, this is it. Tassalis is mainly a rural mosquito. It breeds in fairly clean water flowing, irrigated pastures, rice fields along channels and canals. That's where it is. If the disease is actually widespread outside the city, this mosquito will be responsible for it. So they complement each other. In the rural areas where we have lots of birds, passerines and all, they spread up. Okay, in the city, like what I found out, Modesto has a lot of trees. Actually, it's one of the city with lots of trees. So we have crows. And West Nile virus will literally, in the city, small passerine birds, move it to coverts. They crows and magpies and ravens. Literally 95% of them die, but before they do, they have lots of virus in them, and they can transmit to small birds very easily. Culex does that in the city. Culex pipiens and Tassalis does that in the countryside. So we can have an outbreak of disease literally spreading from the city to the countryside because of those two mosquitoes, and the main ones that transmit most of the diseases we deal with now. Aedes mosquito I mentioned earlier. They are split in three. The pasture mosquitoes, those I'll not dwell on them again as much because they're what they are. They don't transmit disease, but a nuisance. The only part, the feature with Aedes mosquitoes is they lay their eggs on moist soil, on water. But if they do lay eggs on water, it's actually on the meniscus, not directly on water. The other mosquito species do lay their eggs on water. This one on moist soil or any surface that is that water hits. The ground can dry to literally dust. Those eggs will still remain alive. And when the water hits it, they emerge and off they go. That's why you have pasture mosquitoes getting off in a hurry. You dry pasture dry, water comes on, they pop off. And the tree hole mosquitoes behave the same. They stay in, the eggs are laid in tree holes, they stay through summer, no problem. Come the next rain season, they hatch. And then the exotic mosquitoes that we deal with, that I'll talk about later, they are the pain. They are master of the environment around homes as such. And just the details, a little bit of our mosquitoes here. The pasture mosquitoes feed on any host that is available. They just menace as much as they can. Sierrensis, tree hole, dog heartworm, and then the others, I'll talk about it towards the end, essentially. Right? A history and what mosquitoes we deal with up and down in the valley and around here. If you're in town, you're dealing with culex mostly. Now you have another new entrance, exotic Aegypti is in town. You go to the outside, you're dealing with nuisance mosquitoes, and then the disease-carrying one, which is Thassalis, Culex thassalis. The pasture mosquitoes are black in color, heavier, and they don't give up. When they come to you, you swat, they come. You swat, they'll come. They're everywhere. Culex will come in and leave, but they only bite at night. That's the beauty of it. Culex pipiens and Culex thassalis only bite at night. During the day, you call them, what time are you being beaten now? Right now, maybe most likely it's not Culex. The pasture mosquito will bite you in the day. Now, if you're being beaten in the day, and say, what does a mosquito look like? It's black and white. It's a new mosquito we have in town. You get the difference? It's actually very central like that. So when you have call for vector control, they ask you, when are you being beaten? We're trying to figure out the mosquitoes you're dealing with. And when we assess that, when the technician shows up, they know exactly what to look for. Am I looking in the drains? Am I looking in pools? Or should I look in the containers around the houses? And sometimes you can be beaten inside the houses. Which mosquito bites in the house? Very few. Aegypti will actually live inside the house and hangidori without any problem, and will bite you relentlessly because they'll breed in flower pots and stuff. All right? Now, the most important part of what we do is surveillance. Surveillance is a very important portion of our work. What helps us to tell is what mosquitoes are we dealing with over here, over there, over there. And we have proactive surveillance. We go look on a regular basis. And then there's reactive surveillance. And the proactive surveillance is where technicians are out every day. They leave the shop, they go out in the zone to looking for mosquitoes and then to find what it is going on. They walk around with dippers, they walk around doing stuff. That's proactive. Or we go out trap for mosquitoes to see what is going on. The numbers are going up, or what species. We do that on a regular basis. Then there's reactive, where residents, they're being beaten out there, say, damn, I can't stand this anymore. And they call in, please come. A day later, say, you didn't show up. They're eating us alive. And we respond to that. That's really reactive. We don't want to do a whole lot of that. Wait until people are calling relentlessly, but depends on the staff we have and the work we have. It's inevitable. We also use that information very carefully for reactive, for what we do on a day-to-day basis. I go to the District of 3 years ago. We worked literally in pen and paper. Remember 1978, Prop 13 came through and wiped our budget. And I don't have pictures, I should have. We had 25 full-time employees at the district. We went to 3. That's a manager, the clerk, and a mechanic. And then all our staff that do really the heavy lifting, our technician, turned into seasonal staff. Right now we have 5 full-time technicians, and the rest is still seasonal. It's a painful way to run a program. We need staff that know their job and that they're available to work most of the year. But that's what it is. We did everything on pen and paper. 3 years ago, we acquired a software that helps our staff to go out and manage now the work they do on a regular basis better. We have 10 zones, as shown in the picture. And then we have 14 areas that our cab riggers that drive these jeeps, if you've seen them around town. 2 guys drive, and they drive on the right-hand drive. When they're driving, they go with a wand, spraying material into the cabs, and then also gutters to reduce mosquitoes that actually breed underground with us. We normally, in surveillance program, we set up traps to collect adult mosquitoes based on CO2 that we use, and gravity traps, and then biogen traps. I'll show them a little bit later. We collect these mosquitoes, bring them back to the lab, identify them to species. Those species I mentioned earlier, so we can help the staff that are going out to treat to determine what they need to do. But in addition, we take these mosquitoes, essentially identify the species, sex them, and then blood fed status, empty or no blood, or blood fed or mixed. And then we pull them to a max of 50 females in a bottle. I didn't mention these. Mosquitoes, only females take blood meal or bite. The males don't. There's a reason for that. Both male and females take sugar, plant sugar for their energy, for survival. The females take blood meals, their horns, to do that because they need proteins for egg development. Once that is done, they're done. They actually go back for another meal. Every 3-4 days, they develop these batch of eggs, lay them, and go back again. And they live for quite a while. Mosquitoes, depending on the species, some of them live for, what will I say? The shortest, we say 2 weeks. The males, for sure, they're gone in 2 weeks, but the females live for a long time. 2-3 weeks, we measure them, about 7% die every day. So at the end of 2 weeks, there are quite a few still around. And remember, disease requires incubation period, which is about 7 to 12 days. For mosquito to transmit disease, it has lived at least 12 days to 14 days. We have mosquitoes that live for 6 months, alive, adults. The mosquitoes that will bite you this spring, and God forbid, I don't say they should bite you, try to avoid them. Mosquitoes, adults, will be coming out as it warms up. They were adults in October. They didn't lay eggs. They took blood meal and created fat. And they've been hanging around during winter with just consuming fat through winter. They emerge in spring. Those are culex, emerge in spring to take the first meal, lay eggs, and then they die off. So they can live for quite a while. The Aedes died off. They laid the eggs and they're gone. The Aedes I mentioned, they're gone. So it's the eggs and larvae that will develop to the new cohort next year. Egypti does the same. All the Aedes, Anopheles, Anopheles and Culex, they hang around, the females only, to the next season. So they live for a long time depending on species. Anyway, we pull Aedes aegypti for pest resistance because of material we use. And then we also collect dead birds through the state hotline and test them for disease. So once in a while, if there's a disease around, we get the county public health agency epidemiology, they share with us. If they have somebody who has a virus somewhere, they identify in the hospital, clinics, they forward that information. We can follow up and know what's the extent of disease. Sometimes this Zika, chikungunya, or dengue, or any other exotic disease transmitted by mosquitoes, they'll let us know. So we actually work with them to know what extent of disease is. And here are the trap or the surveillance methods we use. The gentleman here, our staff, with the standard dipper, and that's actually a very important tool for surveillance. We go essentially any water standing, we go deep to look how many mosquitoes larvae are in there, what stage, first, second, third, or fourth, or pupae. We count that and use that as surveillance. If you have 100, you have a probe. If you 1 or 2, that's okay. The threshold is about 1 or 2. If you have many, then you have a problem. Sometimes you don't get any, as you did, which is a good thing. The next one, these are traps for adults. On the bottom right is a gravity trap. It uses water that mimics the high ridge organic water that occurs out there, attracts mostly culex, pipiens. This one here, we brew the water and put in those containers, and that is just a toolbox. It sucks mosquitoes in when we turn it on at night. And we go in the morning, we pick up. The number of mosquitoes in there can tell us what is going on in the neighborhood, the species and all. The other two, the top left is biogen trap, and that one uses lure, the smell of our skin. And it has an attraction that we put in there. It attracts mosquitoes based on what actually the smell is. And we set them up, we can add CO2, and it'll double up on that. And right at the bottom here is a CO2 baited trap. We have a canister of dry CO2 at the top. As it releases CO2 sublimes, the CO2 settles down, mosquitoes will come close to that bag below, and they're actually sucked into the trap that runs at night. And then we pick them up in the morning, all the 3. Pick them up in the morning, identify the species, sex, and tell what really need to do in that area. And then the other pools for testing of disease that comes along. Yes, yes.
Do you still maintain any exposed hens? I know they used to.
Actually, no, we don't. I know that the districts, some districts still do, I think Merced do, but most districts have actually left the chickens. We kept the chickens across the state as a sentinel flock. We put them out there, mosquitoes in the neighborhood. If they feed them, the eggs get a Western equine or St. Louis, and the antibodies are picked through it. We bled them every 2 weeks, and that antibodies can tell us what disease is circulating around the area. And most districts actually slowed down and moved away because of the new disease. West Nile virus that came through. It was so ubiquitous that when infected chickens, they will all test positive. And when they do, you have to get new chickens. Otherwise, you'll be feeding the rest of the chickens for the year without any utility. So many districts moved away because that disease became so ubiquitous everywhere. And we don't have chickens anymore. But I really like the eggs, because we consume the eggs, and at the end of the season, who wants a chicken? Really, not just a regular chicken, but a hen to take home. And so folks still ask for that, but we don't keep them anymore. Across the state, only a few districts still have that, most of the big ones. Operation. Actually, this is where really most of our work is done across the state, but our district also do, is operation, where we have the district interacting with the residents and also having impact on the mosquito numbers and the disease. It's operation. Every district that does run a good mosquito program has to have a good operational program. And the east side, when we got decimated, what they ensured to have was to make sure we have technicians that can run essential operational work. They turned them into seasonal, come April 1 to October 31st to run the operation. And I'm so glad we maintained that, because we have staff who've worked for a long time, despite bad time, but they are good at what they do. They know what mosquitoes we have here and how to take care of them. But when they do get the service request, the calls, they know where to go and what to do. But also, when they're not doing that, they're going on a routine, just inspecting properties where it is. We had previous breeding going on, and they know what to do. But when they arrive on a property, they do inspection to determine the source of mosquitoes there and the type of species that we're dealing with. And normally, whatever we do to control, the material we use to control mosquitoes, you have to make sure you know the species and you know what type and the quantity of mosquitoes are dealing there before you put any material out there. And I'll go through these a little bit. So the technician must decide what method, if there are mosquitoes there, what method they're going to use to control it, and also advise residents what they can do to help solve the problem. So the source goes away. And remember that if you have a property artificially altered, the problem is actually the issue of the resident, not us, not the district. But the district has obligation to educate and show. So as we finish and do, we educate, we show what needs to be done, work with us until the mosquitoes are actually gone. But we're going to the source. Remember, the neighbors who are being bitten have no control over the source. We have to focus on the source who are producing mosquitoes. We can apply different material, larvicide, pupicide, and adulticide to control those. And we'll do that. Then come back, set re-inspection, retreatment along the way. What do we deal with when we go to properties? You won't believe, I know many of us keep our properties nice and all, but others really indifferent. Those are the ones that cause a lot of problems. We find this on properties, and the new mosquitoes that we have really love this. They love such an environment. Regular development that the city does, the drain, the sumps and all that, they actually mosquito issues. The northeast of Modesto, we have a lot of sumps and electrovolts that are mosquito galore as such. Some of the mosquitoes, they could live in small areas like that, so don't ignore anything that holds water for 2 to 3 days is actually a source for mosquitoes. The methods of controlling mosquitoes, and I don't know what time now, I did not look at my clock.
About 10 more minutes.
10 more minutes.
There you go. So these are the many ways we control mosquito: cultural methods, behavioral control, chemical, innovative technologies of mosquitoes. We use them all. The last one I will emphasize in a bit. We have many products we use to control mosquitoes, and chemical ones. The top three are no longer in our industry. We don't use them anymore. Biopesticides, juvenile hormone, ecdysone is what we use. And then the microbials, BTI, or Bacillus thuringiensis, Furicus, and spinosad. And then we have botanicals and analogs that we use. Really, most of these material are very environmentally friendly. We use oil, that's only exigent a little bit, to control mosquitoes we can't control. So in emergency, pupae here, we need to put on these and we'll get rid of them. The current mosquitoes I mentioned are environmentally friendly. And then what we've actually sustained on is essentially innovation. The material we have, the chemistry we have, most of the things we use today are focused on different types of mosquitoes. We have single broods or multiple broods. When we put them out, the different families, we put them out to control mosquitoes for a long period of time, depending on the source we're dealing with. And those formulations help us in many ways to control mosquitoes. Our technicians responding to service requests have to make a choice of all this material they need to use to control mosquitoes as we go along. Spraying to kill adults is really the last resort. And I know homeowners say, no, you didn't spray. It doesn't warrant to spray because I found only 2 or 3 mosquitoes. But when we do, is the last resort. If the disease is high, we'll do. When we do, we use several methods, handhelds or backpacks or track-mounted sprayers, and sometimes aerial. Some of the backpack and when the small containers are those stills, and then handheld colds for Aedes aegypti. We have backpack spreaders for dry material, hand cans for some oil, and then the rest of the equipment. Now, different of these sprayed, atomize the material into small particles. The sprayers, 15 to 50 microns, that's a fogging. We have misters, 60 to 180 microns, and then the mist cannon. for spraying actually on water directly, some oil if there's a material that needs to be used inside. And some of the material, the equipment we're trying to perfect is like this one, ATV mounted, is actually new. We haven't taken it as much to the field, but it will help us in those pastures a lot. One of the technologies that have come through at our district essentially is this, is with the software that we have now integrates with our foggers and also integrates with the aerial planes. We have 2 planes that sprays liquid and dry. The liquid one also integrated, so when our staff shows up and sprays, when they're done, the data they actually spray, the footprint they draw, we can see it on the computer at work. And also planes, when they go out to spray, there's no drift. You cannot say, oh, you know what, I was 2 miles away and I got hit by the spray. We can see where the plane was because the footprint is left in our software. And those are 2 planes. The yellow one sprayed liquid larvicide and fogging, adulticide. The red one sprays only granules, dry product. Right? We have only a few minutes, but I want to walk you through the last bit. Aedes, the invasive Aedes. I was in Southern California in Los Angeles. We had a new mosquito there, Aedes albopictus, and before I left, we'd gotten 2 more, Aedes aegypti and the Aedes nodoscriptus. Nodoscriptus comes from Australia, aegypti is from Central South America and Eastern US. Albopictus came actually from abroad, China. And we've gotten, they're all 3 in the state. And I picked up actually 2 of those where they happened. Where I worked, we are the one who picked up nodoscriptus before it was picked up elsewhere. And of course, when I came to here, 2019, within a few months, we picked it up. They sprayed very quickly. This is invasive Aedes, and those are the location where I worked in San Gabriel Valley, and they spread quick. When they get in place, it's very difficult to get rid of them, very difficult. And within just a few years, they spread double, triple, multiple times when they reach in a place. And when to control them, you have to put in essentially 10 times effort to manage to just locate where they are. We only have so many staff, 10, 12 technicians. We cannot get else everywhere, and that's the problem. And nobody has managed to control them. Just to show the example here, you have to put in many times effort to just be able to bear. These are positive location and negative location where we're working 100% ahead. 15 people just focus on aegypti in San Gabriel. We couldn't make a dent. Those are the tools we use for Aedes aegypti. And when they bite, the nuisance is just extreme. The disease is still important, but the nuisance of Aedes aegypti is extreme. Why is it extreme? Is they breed in everything around you. The only mosquito that bites on human, relies on humans only. The females want human blood, nothing else, not cows, not dogs, not human. That's why they're relentless, and they live around people. How many bites are too much? I'm telling you, every bite is very important. 1 mosquito or 2 will terrorize all of us here in an hour. I will all know there was a mosquito in this room. That's how bad that mosquito is. He is a nuisance. I have at least here where I worked there, is when it gets in a place the first year, it's tough. Everybody knows that it's there. The second season it goes down. The third season is actually down. Not that the mosquitoes disappeared, but people have gotten used to this mosquito in place. The first year, very irritating, very, very itchy. As you go on, people get used to it and it calms down. I'm not saying you should get used to the mosquito. When you get it, call in, we'll follow through. What are we gonna do? Only so much. This is index case. We got mosquito here in Modesto, That's a container I showed you earlier. That's a container right there. And I told the residents, say, sir, this container has mosquito. You cannot keep water outside like that. They say, what is the problem? It's just water for my birds. So look at it. Look at the edge of that bucket right above. It's a dark spot. And say, look at this. Let me magnify it. Oh my goodness. That's where it lays the eggs. And once water hits it, it's everywhere. We got the first mosquito right here in Modesto, 2019, and it spread. We had the media in place, and everybody knew about it. In Northern California, we're the northmost. Within 2 weeks, Sacramento, Plaza, San Joaquin announced it because people called and they realized what was biting them. Now it's well north to Shasta. That's a neighborhood. I have this picture for a reason, because this was the index case. We worked these. We could not get this mosquito out. If we control this area, we might have held Egypti from spreading further, because that was the backyard. And we, as we speak, we've never been able to manage these. So with code enforcement and homeowner association, they have not gotten rid of it. Now, that was 2019. Lakewood Scenic Area, East Modesto, 2020. Mar, Roselle, Dry Creek Mobile Estate, 2021, we have in Village 1. If you live or know anybody in Village 1, 2021, calls were ringing off the hook, literally at the district. We could do anything we can. There were only a few, but there was nothing we could change. And we can't fly our planes over there. Our plane cannot fly over residential areas. They're small, single engine. And then the list of the impact of where we found them are there. Just this year, and I said, I don't give up, but we know we have them. Weatherford got it. We have in Riverbank, Oakdale, 2021, 2022 was Waterford. All our districts infested except Night Ferry, and that's it. And what I would say, what we do for this coming year are three things, or several things. We're going to continue proactively, reactive surveillance. Our technician will inspect, will trap, and know where they are. Application live and will continue. Truck mounted misting will continue, and essentially the most important, community engagement, because this is a mosquito problem for all of us. You see something, tell somebody. The neighbors have to know really what bites us is around here. This mosquito only flies 250 feet from birth to death. 250 feet. Just know if you're being bitten by Egypti, it is your neighbor. Either you or your neighbor, nowhere else. It doesn't fly from far, it's right around you. If you get rid of containers, you get rid of it. Community engagement will help us. Sanitation, removing all the stuff that are exposed to sprinklers or rain, will actually do it. Right? Any questions? Yes.
Thank you. Aside from the nuisance value of mosquitoes, they're also vectors of parasites and